In this chapter, we will be describing and contrasting technologies used inside a hard drive and how a computer communicates with the hard drive, selecting, installing, and supporting a hard drive, supporting optical drives, solid-state storage, and flash memory devices. And lastly, we will be looking at troubleshooting hard drives. The first learning outcome, we first learn to describe and contrast technologies used inside a hard drive and how a computer communicates with a hard drive. When we first look at hard drive technologies and interface standards, hard drives come in two major types: the traditional type HDD with moving parts, and a newer, more expensive technology that is with no moving parts, the SSD. We start by looking at the features of a hard drive. Each hard drive technology uses several form factors. A traditional hard disk drive, the HDD, is composed of individual disks or platters with read-write heads on actuator arms controlled by a servo motor, all contained in a sealed case that prevents contamination by outside air. Form factor for internal magnetic hard drives are 3.5-inch for desktop and 2.5-inch for laptop computers. The aluminum platters are coated with a magnetic medium. Two tiny read-write heads service each platter, one to read the top of the platter and the other to read the bottom of the platter. Booting up a computer takes time in part because a traditional hard drive needs to first spin up before the read-write heads can retrieve data off the drive and load it into RAM. All of the moving metal parts of a platter-based drive use a lot of power, create a lot of heat, take up space, wear down over time, and take a lot of nanoseconds to get things done. A solid-state drive addresses all of these issues nicely. In technical terms, solid-state technology and devices are based on the combination of semiconductors and transistors used to create electrical components with no moving parts. In simple terms, SSDs use memory chips to store data instead of all those pesky metal spinning parts used in platter-based hard drives. SSD form factors are typically 1.8-inch, 2.5-inch, or really 3.5-inch when plugging into traditional hard drive ports. SSDs also come in exotic flavors such as M-SATA, a standardized form factor used in portable devices, and M.2 that have special slots on motherboards. Finally, SSDs can install as add-on PCIe cards. Windows supports hybrid hard drives that combine flash memory and spinning platters to provide fast and reliable storage. Low-level formatting is the process where the hard drive firmware, the BIOS, UEFI, and operating system use a simple sequential numbering system called the logical block addressing to address all the sectors on the drive. Today's drive capacity is usually measured in gigabytes or terabytes. However, magnetic drives are generally much larger in capacity than SSDs. Self-monitoring and reporting technology, known as SMART, kind of what it sounds like. SMART is an internal drive program that tracks errors and error conditions within the drive. This information is stored in non-volatile memory on the drive and must be examined externally with smart reader software. There are generic smart reading programs, and every drive manufacturer has software to get at the vendor-specific information being tracked. Regular usage of smart software will help you create a baseline of hard drive functionality to predict potential drive failures. It is used to predict when a drive is likely to fail, and also used by System BIOS UEFI to monitor drive performance, temperature, and other factors. Starting around 1990, an interface called Advanced Technology Attachment, which is ATA, appeared that now virtually monopolizes the hard drive market. ATA hard drives are often referred to as Integrated Drive Electronics, the IDE drives. ATA drives come in two basic flavors. The older parallel ATA, PATA drives send data in parallel on a wide 40 or 80 wire data cable called a ribbon cable. PATA drives dominated the industry for more than a decade but have been replaced by a serial ATA known as SATA drives that send data in serial using only one wire for data transfers. Small computer system interface, powerful and flexible peripheral interface popularized on the Macintosh and used to connect hard drives, optical drives and tape drives, scanners and other devices to PCs of all kinds. Normal SCSI enables up to 7 devices to be connected through a single bus connection, whereas wide SCSI can handle 15 devices attached to a single controller. SATA standard uses a serial data path, and a SATA data cable can accommodate a single SATA drive. One important note to consider when working with interface standards for drives is that the defined data speed and transfer methods between the drive controller, the BIOS UEFI, the chipset on the motherboard, and the operating system. The standards also define the type of cables and connectors used by the drive and the motherboard. SATA cables work for all three standards. SATA support hot swapping, also known as hot plugging. This is the ability of the drive to be connected and disconnected while the system is running. The newest version of SATA that ties capable drives directly into the PCI Express bus on the motherboard. Each lane of PCI Express 3.0 is capable of handling up to 8 gigabits per second data throughput. This is called the SATA Express. A SATA Express drive grabbing 2 lanes, therefore, could move a whopping 16 gigabit per second through the bus. In addition to internal SATA connectors, the motherboard or an expansion card can provide external SATA ports for external drives. External SATA, known as eSATA, extends the SATA bus to external devices, as the name would imply. The eSATA drives use connectors similar to internal SATA, but they are keyed differently so you can't mistake one for the other. External SATA uses shielded cable in lengths up to 2 meters outside the PC and is hot swappable. The beauty of eSATA is that it extends the SATA bus at full speed, mildly faster than the fastest USB connection. It's not that big of a speed gap, especially when you consider that neither connection type fully utilizes its bandwidth yet. But even in real-world tests, eSATA still holds its own. If a desktop system doesn't have an eSATA external connector, or if you need more external SATA devices, you can install an eSATA HBA PCIe Express card or eSATA internal to external slot plate. You can similarly upgrade laptop systems to support external SATA devices, by inserting an eSATA Express card. A quick trip to any major computer store will reveal a thriving trade in external hard drives. External drives connect to a FireWire, USB, eSATA, or Thunderbolt port. All four interfaces offer high data transfer rates and hot swap capability, making them ideal for transporting huge files such as digital video clips. Regardless of the external interface, however, you will find an ordinary SATA drive inside the external enclosure. That is the name used to describe the casing of external hard drives. SATA power connectors, serial ATA drives need a special 15-pin SATA power connector. The larger pin count supports the SATA hot swappable feature and 3.3 volt, 5.0 volt, and 12.0 volt devices. The 3.3 volt pins are not used in any current iteration of SATA drives and are reserved for possible future use. All three generations of SATA use the same power connectors. SATA power connectors are L-shaped, making it almost impossible to insert one incorrectly into a SATA drive. No other device on your computer uses the SATA power connector. NVMe Non-Volatile Memory Express SSD technology supports a communication connection between the operating system and the SSD directly through a PCIe bus lane, reducing latency and taking full advantage of the speeds of high-end SSDs. NVMe SSDs come in a couple of formats, such as an add-on expansion card and a 2.5-inch drive, like the SATA drives for portables. NVMe drives are a lot more expensive currently than other SSDs, but offer much higher speeds.